It's 5mm mild steel. Let's give this a try. According to the dial, I made it just a hair over 8 tons. There's a slug that came out the bottom. Guess my stringer spring could be a little bit stronger. Not too bad. Let's try 8mm. About 12 tons. Made it to about 15 tons. There's the slug for that. All in all, looks pretty alright. I think I need a stronger spring, or well, after that, this shouldn't be a problem. This is some sheet metal, I think like a drywall stud. Just want to see what how clean the hole comes out of this. I don't even make it to 200 psi. So after that chop press build, I thought it might be interesting to take you guys along for this other ride. This, what you see here, is what will become, hopefully, my first punch and die set. I got some of these two pieces are tool steel. This is a K100, and best I can tell, it's about a D3 equivalent. And I may use that for the die. And this is a silver steel or drill rod. This is about 6/10 of an inch in diameter. It's about the size, 15 millimeters, about the size I thought I'd start off with. This is like a W or an 01, something along those lines. I'm not exactly sure what the silver steel translation is. This is the biggest spring I got, and I'm thinking about using it as a kind of a stripper. I don't know what thickness material. I have an idea of sort of the average, and that's what I'll use to add clearances to the die. But I thought this might be a little more handy than, say, like a fixed stripper plate. That's the attachment that you guys saw in the shop post build. So I'm thinking just like a shoulder to hold the spring, like a floating donut, let's call it, act as a stripper, and then this punch on the inside. And hopefully none of this will move around too much when I try to heat treat it here in the garage. So the battery on this camera died, and I apologize for poor planning on my part. I usually, decide to make a video kind of last minute and try to find all the bits and pieces. But you didn't miss much. So I basically just, again, nothing exciting. Just took turned these pieces out of it. This is what's going to hold the punch. Now it's probably not ideal to have a two-piece punch. I'm guessing there. I've usually seen them with a nice, beefy taper, you know, where they transition. But hopefully this will do the trick. And it's just got a bore for 15mm drill rod. Wrong way. And I tapped a little hole. There's a through hole there and a countersink for a little M6 screw. So the spring goes on like this. That's a sort of a slip fit there. Let me put it on this side first. This is a bit of a tighter fit. I didn't want it coming off of that end. That fits in like that. It's a little marker. And that should hopefully work as my stripper. I don't know if that's beefy enough to strip this out of tool. I suppose it depends on the die clearances that I have, but I can always replace this with something stronger, or maybe even like a urethane spring. So that's tooling, should fit in the press now. Next we got to build the die. This is 14mm. We're shooting for 15. So we're going for 15 nominal. I wouldn't usually drill straight with a 15mm drill, but I know this one happens to drill a little bit undersized. This will get us to 14.9, something about that. And then we can go in and part these off and clean them up with a boring bar. I always get a little bit nervous with tool steel. In my experience, it seems like you hesitate just a fraction of a second, and next thing you know, it's impossible to machine anymore. 3/4 of an inch, I think, should do it. Gave it just a hair more so we can clean up the other side with a facing cut. Okay, so we managed to part off a couple of these 3/4 inch thick dies. I just set this up quick and took a quick clean-up cut. Just face that off. Now I'm going to go in with a boring bar. Clean up the sort of that nominal diameter, and then cut about a 2-degree taper after, say, the first 1/4 inch seems like a lot. Maybe a hair shy of 1/4 inch, 5mm or so. Since we're only talking about 2 degrees of draft, it's going to be hard to see that inside of there, especially inside that 15mm hole. So what I'm going to do is I'm going to go into the bore until I see the boring bar come out the back side, touch off there, and start my 2 degrees in the back, and watch that land increase until I come into, again, that 4 or 5mm from the front. Okay, it looks alright. I think the back of my boring bar might have done a little bit of rubbing there. Just eyeball that. Three millimeters. Just like we said we were going to do. Okay, I lost some video there. Hopefully this punch and die will work better than my video skills. Basically, you saw me flip the die over, just try to square it up with the parallels, and I cleaned off the back side. Now what I'm going to do is switch this out, put it in the 4-jaw, and I'm going to bore this, just a piece of block that I had in the bin, to take that die. Just kind of a temporary support. I've got a little punch mark on there. I mean, it's not critical, but it'd be nice if it was pretty close to center. And I've got my I've got a center on here. I'm just going to eyeball that punch mark in. I just counterbored a hole in this block, take the die, like that. It's sticking up maybe 1/30 thou or so. And now I'm just going to take it over to the mill and put in a couple of holes for some countersunk screws. That way I can hold this down. And I might pin this through the side. I'm not sure what the best way to keep the die from, coming back up with the punch. But I think just like a spring pin through here. Maybe a set screw, but I think a clean spring pin hole or a roll pin hole might be easier to sort of pick up when I make another one of these, so I can clamp the whole thing in, pick up that same hole, and just drill the next die. Alright, so we've got our 2M8 screws and the little bores for the roll pins. Alright, so we've got all our parts laid out. I think that's everything, but at any rate we need to harden these a bit. So I'm going to get the punch and the die, move some of this stuff out of the way a bit. So I'm no heat treat expert, but I think anything we do to these is going to help to improve tool life a little bit, as long as they don't end up too brittle. So what we're going to do is temper them, get them as hard as they could get, and then try to draw some of that back. I go by the oxidating color technique. I have no real control over this. Like, again, this is very Mickey Mouse type heat treating, but again, I think anything we could do shy of getting them too brittle is only going to help us out. I've got all my stuff out, protective equipment, I got the apron on, I've got some oil here, This may just be superstition, but the oil's at room temperature here, which is about 17 degrees. So 17 degrees, what I'm going to do is just heat up a piece of scrap. You can see it's done this before. Dunk it in the oil and that'll just knock some of that edge off of it. I always try to get that in there sort of as square as possible, and that's where these little fishing poles help out. If you dunk it at a bit of an angle, you'll get some differential cooling, and your parts will turn into bananas, and just won't be a happy scene. Alright, so if all went well, this side should still be softish. As you can see, that's sort of cutting in the file. And I'm just skating off the end. Next up is the die. Okay, so the die didn't turn out so well. I had to quench it again. It came out soft. So I could scratch it, I could cut it with a file. I think what happened is I'm running low on oil, and the preheat plus dunking the punch probably got that too warm and I didn't get enough sort of thermal shock, let's call it. And this didn't harden quite fast enough, so I just waited for this oil to cool down. Not really room temperature, just because I wanted to get this done. But chillier than before. Went through the same exact process, dunked it, and now it looks like I can still kind of get into the backside, but the top is skating nice. There's a couple of spots, I think back here is a little bit warm. I'm going to call that good. Okay, so now these things are hard. We want to sort of draw that temper back so it's in the sort of the tool range. And for me, that's typically something like this. Going by the oxide color is about a yellowish, a straw yellow. But in order to see that, we're going to have to get all this oxide and scale and goop off. I'm going to do this on the lathe. Alright, so the four-jaw chuck is on the lathe. That's not going to help our cause here. Man, that's a lot to get off. Alright, that should do it. Alright, we'll meet the world's sketchiest heat treat furnace. Don't worry, I did my toast before this. So I've set it to about 200. It's anywhere from the 230, 215 range. That's probably about as accurate as I can expect from either the toaster oven or the thermometer here. I'm going to call that good. I've got a couple of tiles in there. I'm just going to put the parts in between the tiles just because I don't want any participation from the radiation from the elements. In the past, that's kind of come back to bite me in the butt because it gets a lot hotter. You can get your parts a lot hotter than what the internal temperature is. I made just a simple little wire form just to hold the punch up and keep the tile off of it. About 201. I dropped the temperature a little bit from before. I don't usually keep the door open this long, but I don't think it'll hurt anything. So that's what the setup looks like. We'll just leave that cook. Okay, so they're in about an hour and a half. I don't know if you could tell what color they are. You probably can't, because I had a hard time myself. I had to take them out into the daylight. It's hard to do this kind of stuff under any kind of artificial lighting. But there's a piece of white paper for comparison, and you can see sort of that yellow oxide on there. Could have been just a hair darker, maybe. Could have gone a little bit hotter. I took the measurement on the tiles, the temperature measurement on the tiles. That was about 205, 206, you know, within whatever accuracy that thermometer might be. Probably plus or minus 10 degrees. But I think this should do the job. I mean, I'm not trying to win a Nobel Prize here. But for just kind of playing around and, you know, the amount of use it'll see in my hands. That's just some oil goop there, cooked on oil. I think these should do the job. So the next step is to touch them up a little bit, get them sharp, and we can give them a try. Alright, so why not just keep trying to pile on the hacks here. I've got the punch in a collet chuck. I've already dressed the smallest stone that I have for this. I'm not even sure how long this is going to last. I'm trying to do this. And I've got a homemade tool post grinder. This is set on 0. The top slide is 5 degrees. And what we're going to try to do is get a little bit of a dish, a concave cut in there to try to get sort of the required tonnage down and get sort of the perimeter exerting most of the force. So we'll give this a try. I'll start in the center and start working my way out. I think that way should be a little bit safer in that I expect this wheel to wear down quickly, so by the time I get to the outside I won't accidentally cut a concave shape, make things worse for me. I don't know if you guys can see how much this is here. It's maybe 30 thou in the middle. I mean, I have no idea if that's, maybe it looks better that way. If that's enough or not. It's not like we're trying to make a watermelon baller here. Let's give it a try. Would you believe it took me about 20 minutes to find this piece that I just made? Battery died and I lost that last clip, but all I did was get the die in the tool holder with a couple of roll pins. So let's get the rest of this together and try this out. Alright, so this will go. Again, this is just temporary. Alright, this is 3/8 about 9.5 millimeters. See what happens. About 15 tons, then it started dropping away. That mark there is from this bend. Pretty alright? That feels okay. Alright, I think we just need a bigger stripper spring. Here's a slug, by the way.